Dear physics aspirants, right now I have the common forces in mechanics, and you will see here figure 5.9 some examples of contact forces in mechanics. You will see here, and here is the description. Common forces in mechanics. In mechanics we encounter several kinds of forces. The gravitational force is of course pervasive. Every subject on earth experiences the force. Every object on the earth experiences the force of gravity due to the earth. Gravity also governs the motion of celestial bodies. The gravitational force can act as a distance without the need of any intervening medium. All the other forces common in mechanics are contact forces. As the name suggests, a contact force on an object arises due to contact with some other object, solid or fluid. When bodies are in contact, e.g. a book resting on a table, a system of rigid bodies connected by rods, hinges and other types of supports. You can see here. You can see here. There are mutual contact forces for each pair of bodies, satisfying the third law. The component of contact force normal to the surface in contact is called normal reaction. The component parallel to the surfaces in contact is called the friction. Contact forces arise. Contact forces arise also when solids are in contact with fluids. For example, a solid immersed in a fluid, there is an upward buoyant force equal to the weight of the fluid displaced. The viscous force, air resistance, etc. are called the examples of contact forces. Figure 5.9. You will see here. The two other common forces are tension in a string and force due to spring. When a spring is compressed or extended by external force, a restoring force is generated. This force is usually proportional to the compression or elongation. For small displacements, the spring force F is written as F is equal to minus kx, where x is the displacement and k is the force constant. The negative sign denotes that force is opposite to the displacement from the unstretched state. For an extensible string, the force constant is very high. The restoring forces in string is called the tensions. It is customary to use a constant tensions T throughout the string. This assumption is true for a string of negligible mass. In chapter 1, we learned that there are four fundamental forces in nature. Of these, the weak and strong forces appear in domains that do not concern us here. Only the gravitational and electrical forces are relevant in the context of mechanics. The different contact forces of mechanics mentioned above fundamentally arise from electrical forces. This may seem surprising, since we are talking of unchanged and magnetic bodies in mechanics. At the microscopic level, all bodies are made of charged constituents, nuclei and electrons, and the various contact forces arising due to the elasticity of bodies, molecular collisions and impact, etc. can ultimately be traced to the electrical forces between the charged constituent of different bodies. The detailed microscopic origin of these forces is, however, complex and not useful for handling problem in mechanics at the microscopic scale. This is why they are treated as different types of forces with their characteristic properties determined empirically. So we have studied common forces in mechanics. Next video we will discuss friction. Till then, thank you. Thanks for watching the video. Thank you.